wanted to go over a quick example of the new load testing in DB Optimizer 1.5.1. So this load testing is brand new for the 0.1 release of 1.5. And I'll start up right now. The load tester is this dial, like an RPM dial with a red line on it. I'm going to click on it. It comes up in the area where I can either type in SQL or read in a SQL file. I'm going to cut and paste from an editor I have open. So I'm going to take a relatively complicated piece of SQL, and here's the SQL. So it's fairly long, and I'm going to run it by, let's say, 10 users, and I'm going to run it by number of executions. I'm going to run each user is going to run it 10 times, and I'm going to take random interval between the executions. So let's say about 1.9 seconds to like 2.9 seconds. And then before I run it, I want to start profiling the database to see what kind of load this puts on the database. So I want to connect to a data source. Connected. I'm connecting to the lab system. It's the last one I was connected to. And I've started profiling it. So profiling again is done with a little chart icon. So there's no activity in the database, or very little right now. It looks idle. So I'm going to run my load, hit the execute button, and then go back and check out and see what happens on the database. So here we see the load coming on. Remember, I have 10 users, so you can see the 10 different users coming on, the load they're putting on. It's using up a lot of CPU. We can see I have 2 CPUs on this machine. The number of CPUs is shown for the Oracle platform. It's not shown for the other platforms. And when the CPU usage, the green, goes above that line, it means we have CPU contention on the box. So right now, this database doesn't really support efficiently the execution of these 10 users running this query between about 2 and 3 seconds at random intervals. So I'm going to tune that query. So I'm going to right-click on the query. Oops. So that's the at the bottom is the details, but I don't really care the details. What I want to do is try to tune that query. So right-click, choose the tune, and this will open up the SQL Tuner. So now we have SQL Tuner opened. It automatically pastes in the query, and I'm going to hit the Generate Case button. So Generate Cases takes me to the next tab, Generate Cases. It'll populate it with the base case, the default case, and then it will try to find different execution paths using the hints on the database. Now this is good. I mean, in most cases the database is going to choose the correct path, but what do we do in cases where the database doesn't choose the correct path? It's very difficult to find out if there's a better path. How do we do it? Rewrite the query. Try to find ways of forcing the optimizer to use a different path. Here we're going to do all the work automatically. We take the Oracle hints, find out which ones apply to the query, insert them to the query, generate execution plans. For those hints that are applicable and generate the same execution plan, we collapse them so we don't show duplicates. It's quite a bit of work to do by hand. Here we do it all automatically. Once we have the cases generated, then we'll be able to execute them and see which one, if any of them are faster. We'll be able to determine whether the database's native optimizer chose the correct path or if there's actually a better path. And we'll see what hints we can use to force that better path. So here it's going through. You can see as it's unchecking the hints that are producing actually the same execution path or duplicates, and we'll compact those so that the only ones that are remaining are the unique ones. So here we have our unique ones. Now we can run the query. I'm going to hit the execute button, and it'll start executing these different paths. What we're interested in is if any of the paths are faster. So automatically DB Optimizer will cancel any generated case that takes longer than 1.5 times the base case. So after we go through, so here's the one where it canceled that little blue circle with a white X. It canceled. It took longer than 1.5 times the base case. Once we have all the cases executed, we can sort them by execute the elapsed time. So I'm going to click on elapsed time. And we want to choose basically the one that took the least amount of time to execute. So in this case, it looks like all rows is the quickest one. And we can also verify that by looking at logical reads and CPU time. So to get the actual text with the hint, we just click on the text, and I'm going to cut and paste it. Copy it, and I'm going to open up another load editor, and we're going to run this new version of the same query. Remember, I ran it by 10 users, and each user ran 10 executions, and I used a random interval. The reason I'm using random instead of fixed time is because we sample, in order to profile a database, we sample it once a second. So anything that runs with runs at the same cycles, same frequency, risk to be show up not in a statistically satisfactory manner. So here we're using random. It'll be a better sampling of what the actual load looks like. So here's our load from the first run through, and now we can see our second run through coming on. And the question is it better or not? So this is the same load as the first time. And we can see in the bottom left that the load is executing. Now it's finished, so we're already finished. So you can see that it executed in a less amount of time. So there's 5 bars here, and there's 1, 2, 3, 4, 5, 6, 7 bars. Just to run the comparison again, we'll take our query. Here's the original query with a default optimization by the database, and look at profiling. And let's see what kind of load the original query had. You can see the loads coming on. It already looks higher than our optimized one. It's getting even higher. So this is at 3 bars wide, 4. Remember, it took about 7 over here. 5 bars, taking up a fair bit of load on the database. Remember, green above the number of CPUs means there's contention for the CPU. And we see in the bottom left that load is still running. Still running. And we're looking at some other contention. Now it's finished. We can see the execution is over. And we can also see what that contention was. I pull my little slider, and it's latch cache buffer chains. It means there was contention for blocks in the memory. So now let's just run it once more for a sanity check. So this is our optimized one that came from the tuner. So apparently Oracle's native optimizer didn't pick the correct path, and DB Optimizer goes through all 80 of Oracle hints, determines which ones are applicable to the query, generates execution paths, eliminates any duplicates, and we find out if there's a quicker path by executing it. And in this case, yes, indeed, there's one that's quite a bit more efficient. This would have been a tremendous amount of work. This is a real-life query that came from a financials application. And you can see that the query ran faster, only 5 bars, and put a lot less resource pressure on the system. Actually, there was basically no CPU contention, maybe a teeny tiny bit. But for the most part, we were at the maximum, using up to 100% or less. So that's an example of the new load tester and using the tuner to tune a query.